This is the Digital Factory podcast. I'm John Brunner. Our conversation today is about a future in which things are made through distributed, decentralized networks of fabrication facilities. It's a discussion with the CEO and co-founder of 3D Hubs. His colleague, the other co-founder and chief product officer of 3D Hubs, is speaking at the Digital Factory conference coming up on May 7 in Boston. Other speakers there include the CEOs of Align Technologies, Spirit Aerosystems, PTC, Formlabs, Desktop Metal, Onshape, Bright Machines, the CTOs of GE and Baker Hughes, the CIO of FedEx, the head of manufacturing at Ford, the head of Fusion 360 at Autodesk, and a lot of other authorities on digital manufacturing. You'll want to be there, and to register, you can use the code PODCAST when you visit thedigitalfactory.com. The Digital Factory is supported by Formlabs, which makes powerful, accessible 3D printers that scale from desktop prototyping into full production. My guest today is Bram de Zwart, who's the CEO and co-founder of 3D Hubs. Bram, it's great to have you on.
Great to be here.
I'd love to start by just having you describe exactly what 3D Hubs does. You've been a big part of the 3D printing ecosystem for a long time. Recently, you've shifted the business model just a little bit to serve more of the high-end commercial market. So tell us in your own words exactly how you see 3D Hubs.
Yeah, indeed, it has changed a bit over time, but our vision has really stayed the same. And we believe that the future of manufacturing is going to be a lot more automated. It's going to be a lot more distributed. And this will create a world in which there's less transportation, there's less overproduction, because you can make parts when they are needed and where they are needed. That's our vision since the beginning. We started very much as a peer-to-peer marketplace where people could get something 3D printed in their neighborhoods, typically someone who had a printer like a Formlabs or an Ultimaker in their garage. And we now shifted more towards industrial clients and industrial manufacturers. And now we really make it super easy for industrial companies to outsource their manufacturing, not only 3D printing, but also CNC machining and injection molding. And we reduce the time it takes for them to get their design in production somewhere on a machine in the world from weeks to minutes.
And so that transition that you made last fall that you mentioned is really interesting because I think it says something about the direction of 3D printing in general and the way that kind of industrial and commercial 3D printing have moved apart, have opened up kind of a bigger gap over hobbyist 3D printing. So to go back, originally 3D Hubs was a big network of people ranging from hobbyist 3D printers up to commercial providers. You could send jobs to any of them. And last fall, you transitioned away from having the hobbyist 3D printers be part of the network. What did you see in that transition? I mean, what was the motivation there?
Yeah, it was, we had 30,000 3D printers connected on the platform, but we discovered that really the majority of 3D print demand in the market today is not with consumers, is not with hobbyists. It's really with companies, and especially industrial companies. And we learned that these industrial companies, they don't want to run the risk of getting something printed in a garage somewhere with a consumer, what it does to quality and other liabilities. So that's why we decided we want to serve this industrial market. That's where really the opportunity is right now. That is what's growing the fastest. And in order to do that, we're going to not work with 30,000 individual 3D printer owners, but we're going to work with 200 highly certified industrial manufacturers.
This is something that is referred to a few times in your most recent 3D Hubs Trends report that came out a little bit earlier this year. There's a big emphasis on standardization, on the release of ASTM standards around 3D printing as a big part of 3D printing becoming integral to a lot of industrial components. So it seems like the entire movement here is toward kind of standardization, auditable manufacturing trails, suppliers who meet your requirements from beginning to end. Feels like it's becoming a much more kind of industrialized and standardized process altogether.
Yeah, I think that is really a reflection of 3D printing becoming ready for functional and end parts, and therefore industrial clients, industrial companies expecting kind of the same certifications, the same standards as they were used to with other production technologies. And I think it's a really exciting development, but it's also challenging for the industry and for us in order to meet those new requirements that I think the industry wasn't used to as much as we were initially mainly making prototypes.
I tend to think of the 3D printing market in not just terms of, hobbyist 3D printers and 3D printing on one end and industrial on the other, but really kind of three big clusters where you have hobbyists on one end and giant industrial machines on the other. But then in the middle, this rising category of kind of mid-priced or low-priced professional machines. Obviously, at Formlabs, we have a horse in this race, but there are a lot of companies operating here. I would even say that Desktop Metal is one, where it's brought the cost of metal 3D printing down by an order of magnitude. Where do you see those printers fitting in? Is that an emerging field in your market?
Yeah, we see a really increased demand for those types of high precision printed parts, and it's really amazing that companies like Formlabs are making that more accessible. It has allowed us to really build a big distributed network now on 4 continents, where before, when the machine still costed hundreds of thousands of dollars, that was a lot more challenging. So these developments contribute to the further decentralization of manufacturing, as they kind of reach the same quality as we were used to with much more expensive machines, and also start making it more competitive with injection molding techniques, for example, like more mass production manufacturing technologies. And so I think that's a really exciting development. It's all contributing to this decentralization, which will make manufacturing more accessible and will make the world run a bit more efficient.
In terms of this decentralization, so you've moved to a model where you have a few hundred suppliers, a few hundred contractors in your network. How many contractors do you see yourselves having eventually? Is this room for hundreds of thousands of contractors, like several in every small town, or do you see this kind of getting to the point of having regional hubs for 3D printing?
I think you'll see more regional hubs. I think it will also depend, of course, how much of global manufacturing demand we will be able to funnel through our platform and through our network. But where we came from, which was indeed a 3D printer almost on every street because we had 30,000 printers connected. It's hard to really generate enough demand for each location to make it worthwhile, right? And especially as more of the ancillary processes around 3D printing will be automated through robotics, you need a certain skill, I think, to really make a location be successful.
Tell us about the typical location. How big is it? What kind of experience does it have? What sorts of machines is it operating?
I'd say our best 3D printing locations are the ones that start doing it as a hobby on the platform like 6 years ago. They did it in the evenings and weekends, and then they saw there was money to be made, and they were really passionate about the technology, so they decided to quit their other job and build a full-time business out of it. So typically, locations that have about 10 or 20 printers are very, very excited about this vision that we have.
Tell us about the CNC machining services that you're offering now. That seems like on the one hand, it's similar to offering, a network of 3D printing providers. On the other hand, it's a completely different set of technologies with a completely different set of limitations and a lot of, very different processes around bidding for the work and doing the CAM and so on.
Yeah, CNC machining is a very different technology from 3D printing. It requires a certain skill. The machines are bigger. There's a higher upfront cost because the CAM programming can take quite a bit of time and it's very expensive typically. But it is a very, very big market. What I'm seeing a lot bigger than 3D printing even. Mm-hmm. And it's great to make high precision metal parts. It's a great technology for that. What we're seeing with machining indeed is that the facilities that have those machines are a lot bigger than a typical 3D print facility. They typically have around 50 machines, each worth several hundred thousands of dollars. But what's interesting about CNC machining is it's not as hyped as 3D printing. But it's a very big market, and it hasn't been touched as much by companies like us that are with software trying to automate a lot of manual processes that still make this CNC market very intransparent and very inefficient. So I think 3D printing is a very exciting technology. It will probably become bigger than machining over time. But today, machining is really where we see a lot of growth potential as well. And it's a digital manufacturing technology in the sense that you work with a CAD file and you can automate a lot of processes with that CAD file. But very few companies have done that so far. And so that's why we see a lot of our growth recently coming from machining.
And of course, as you point out in the report, 3D printing is only ever a small part of a process, right? And this is, I think, something that a lot of people overlooked at the birth of the modern 3D printing era, 5 to 10 years ago, when they sort of felt that 3D printing was the answer to a lot of things, that 3D printing would be used to fabricate entire products. And of course, it turned out that 3D printing winds up being valuable as, one out of several manufacturing processes and can kind of elevate the others. So by offering everything, you wind up, providing the entire value set.
Yeah, it all works together. It's one big ecosystem, and 3D printing is a great technology, for example, to make molds for injection molding. It's a great technology to make jigs for to hold parts on the CNC machine. So it all works together, and 3D printing is becoming increasingly important there.
So let's talk about the industries that you see coming through the platform. Aerospace, of course, is held out as a real leader in 3D printing, and the industry that has developed a lot of the modern 3D printing processes and the way that they're used in manufacturing. And then you have sort of automotive, which is a couple of orders of magnitude larger and is just beginning to get into 3D printing in a serious way now. In your report, though, you mentioned that aerospace in particular tends not to outsource much of its 3D printing, and it looks like automotive is doing a lot of stuff in-house as well. What do you see in the way that different industries tend to outsource their 3D printing versus develop in-house capabilities?
Yeah, I think you have to look at different factors. For example, how regulated an industry is, right? If there's very strict regulations and certifications needed, I think companies are more inclined to do it in-house than outsource it potentially. But yeah, it depends, right? We're seeing more adoption for our on-demand manufacturing model with small, medium-sized companies than very large enterprises, which have much stricter regulations they have to deal with typically. I mean, we have put our parts on satellites, for example. So one company is more inclined to go with innovations like ours than others.
Is there a way to sort of offer, highly regulated or highly standardized supply chains through a service like 3D Hubs with all of the industrial certifications that you would require if you're an aerospace manufacturer?
Yeah, that's of course one of our challenges, but one of the things that we're doing is really mapping all the certifications that our manufacturing partners have, and then allowing our clients to indicate that in the online ordering process. So as we source their orders, we only source them with manufacturing partners that have the right certifications. So that's one thing you can do. You can implement things such as first article inspection. There's a lot of things you can do, but there's probably a limit. For example, in medical sectors like implants, it becomes a bit more tricky. I wouldn't say it's impossible, but that requires quite a bit of work.
So beyond the simple availability of 3D printing and other, digital manufacturing technologies themselves, how do you see this kind of globalized network of local fabrication changing the way that we develop and deliver products?
Yeah, I think it really lowers the threshold for companies to develop hardware and bring products to market. Historically, it takes a lot of time, right, and a lot of resources to bring a product to market. I studied industrial design engineering, started in 2002. And the first thing the professor said, only 10% of you will design products that actually hit the shelves. Because back then it required a certain skill and resources to bring products to market. And I think, now with the development in CAD, but also now the development of digital manufacturing technologies combined with platforms like 3D Hubs, it becomes so much more easier and so much more faster to create a design and bring it to market. So the invention of Kickstarter makes it very easy for companies to crowdfund their projects and bring products to market. And I think that really fits into digital manufacturing and online platforms like 3D Hubs, which also reduce the investments needed to get those products to market. And interestingly enough, I found out that 84% of Kickstarter projects ship late. So I think a lot of the companies, they haven't discovered online platforms like 3D Hubs or digital manufacturing in general, which I think would allow them to get to market much faster, right? I think what many, especially newcomers, underestimate is that to get a product to market, it requires sometimes dozens of iterations, and each iteration can take many weeks if you're not working with a modern manufacturer that is very slow. And so with 3D Hubs, we've created a distributed network, which means there's always instant capacity available. And within seconds, we tell you the price of manufacturing. And we tell you if your design is actually manufacturable. Mm-hmm. And so it means you can really go into manufacturing in a matter of minutes instead of weeks. And that, of course, has compounding impact on the time it takes to get to market and get to revenue, as you have to go through dozens of iterations typically.
It's interesting to think back to the kind of the height of the maker movement and the moment when a lot of people felt that the maker movement was a precursor to a larger kind of commercial movement where anyone can develop hardware, anyone can use these tools and create physical objects the same way that you can create software. One of the things that I think we now look back on as a little bit of a miscalculation was the idea that everyone would become, a physical prototyping engineer in addition to being something else. And so you had this idea that, people would operate CNC machines firsthand, operate 3D printers firsthand, prototype solder microcontrollers and other embedded electronics firsthand. And it's been interesting to see that while it's true that more and more people are able to understand and experience these things firsthand, when it comes to developing products, the infrastructure for sort of sending stuff out and not having your engineers be machinists all day has become much larger and more sophisticated and more widely used.
Yeah, no, I think the whole hype, it was very exciting. It's an exciting vision and it gives empowerment to people. But just like Photoshop didn't make everyone a good graphic designer. Mm-hmm. You see the same with 3D printers, right? It doesn't make everyone a great product designer. It allows more people to experiment with it. That is great, but it still requires a certain skill set. Yeah.
What and tell us about that skill set. I mean, I think you have to know something about 3D printing in order to really get its full value out of 3D printing. You have to sort of know how to design for it. It's not just about taking a part that's been injection molded and sending it out to be 3D printed instead. So what do designers and engineers need to understand about 3D printing in order to get real value out of it?
It starts with many people even not knowing that 3D printing is basically one word for many different technologies, right? You have powder-based 3D printing, you have liquid-based 3D printing, you have filament-based 3D printing, and they all have very different characteristics and design rules. So I think that's the first lesson engineers should learn is it's basically one name for several different processes. I think what's really exciting is that it allows engineers to think about design in a different way because it gives the most design freedom of all manufacturing technologies out there. But it can also be a bit scary, right, for engineers, because once you can do everything, like where do you start? Sometimes it's nice to design within certain boundaries that are well known in the industry and have been there for decades. And then suddenly someone gives you an empty sheet of paper and you can do anything. And like, where do you start? But I'd say those are important things. At 3D Hubs, we have written a book called the 3D Printing Handbook. And it is 300 pages of explaining these opportunities, but also there's still limitations with 3D printing to engineers. But I'd say in general, it's really about having more design freedom, especially with SLS technology and SLA to a certain extent, and FDM to a lesser extent, right?
In most recent news, you've raised a big round of capital, $18 million from investors to expand. What are you looking at doing there?
Well, our goal is to build the platform where companies outsource their manufacturing, and we want to make that super easy. So we'll invest heavily in automation of all the processes that happen before manufacturing begins. So think about quoting, for example. Quoting today, when you want to get something made, can take weeks. You can get a 3 times difference between different manufacturers, and there's no clarity why. So that's something that we want to automate and make more transparent. And so what we already do today is reduce the time it takes to get your design into manufacturing somewhere from weeks to minutes. But there's a lot more we can automate, and that's something that we'll heavily invest in. Besides that, we're also expanding in the United States. We already have about half of our revenue coming from there, and we see a lot of growth potential there.
And so this kind of automation you're discussing, it involves writing software that actually understands the geometries of the jobs that are submitted and how they relate to 3D printers, right?
Yeah, that's right. So it starts with a client uploading their CAD files, and then we extract 40 parameters from that, which we feed into our machine learning, into our deep neural networks. And based on all the historic pricing, we can then, in a matter of seconds, predict the price of production. And we now do that instantly for 98% of projects, and we guarantee that price independent of what it costs us to source that.
So at 3D Hubs, it seems like one of your big advantages that you're developing is that you're kind of the center of this large marketplace. You're developing a lot of data. You're able to see how the marketplace works, how pricing works, how quoting works. Where do you think you can go with that in the future, especially as it relates to, the ability to maybe drive quoting processes with AI or machine learning?
Yeah, I think really the manufacturing market should become much more transparent in their pricing. If you're a client and want to outsource your production, it can take weeks to get a quote, and you can get 300% difference between two different suppliers, and you have no idea why, because you gave them exactly the same specs. And I think what's really exciting is that now with indeed big data and machine learning, it will allow us to calculate a fair real-time price for manufacturing based on patterns we're seeing in the market, based on real-time capacity in the market. And you start to see some parallels with the stock market. In the non-public markets, in the private markets, or before there was a stock exchange, you had to negotiate the price of shares in a company. Now, with the stock market, it looks at supply and demand in the market, and based on that creates a share price. And I think we can achieve the same with manufacturing. We can achieve a price that everyone in the market will accept, and is constantly updated with training data, which gives insight into real-time capacity. So I think that's where the market will go eventually.
You could even imagine the participants in your marketplace, the contractors who fabricate things, developing their own kinds of algorithms for bidding, right? And this way you kind of come up with a competitive process with a lot of inputs, and then you're sort of in the middle with your ML algorithm, moderating everything, forecasting, keeping things kind of flowing together.
Yeah, possibly. Yeah, the way we work today is that we already calculate the price for manufacturing, and in 70% of cases that is instantly accepted by our manufacturing partners. Mm-hmm. So they start to rely on our algorithms more and more, and I think that's the beginning of a development where hopefully the whole manufacturing market will accept our pricing algorithms as being fair and a reflection of demand and supply in the market.
Bram, I'd like to ask you the question I ask everyone who comes on this podcast. What is your favorite tool?
Well, mine is favorite tool is a Dutch bike.
Okay.
It allows me to get around in Amsterdam and get everywhere in about 20 minutes. That's great about Amsterdam. You can get anywhere by bike really fast. And what I really like is the electrification of bikes happening right now. So you have some really cool brands that really want to become the Tesla of bikes and start to deploy similar features on bikes. So it's really an area I like to watch now. And so, yeah, being Dutch, I'm all about bikes.
What does a Dutch bike mean? What's the meaning of a Dutch bike in particular?
Well, historically, it was probably a very cheap bike that got stolen twice a year. And in Holland, we actually have more bikes than people. So there's
it's a pretty liquid market.
Along a lot. Yeah. And they fall apart a lot as well. But now it's really like you see the market changing, and you see bike sharing services coming up. You see electrification, so you see similar dynamics as in the car industry on bikes, and where they used to cost like $200, they start costing several thousands of dollars. But if you don't have to use your car anymore, I think that's really worth it. So
yeah, I live in San Francisco, and my life has been transformed in the last few months by the introduction of electric bikes in the city bike sharing program. So you just go to any dock and with your subscription can check out an electric bike and replace it at a different dock. And having the motor assist makes it the absolutely perfect way to get around. It was already a very good way to get around San Francisco because the weather is so favorable for it all the time. But now that you have the motor, it just completely obliterates any misgiving that you might have about getting on a bike. I'm a little too tired to ride my bike somewhere. I don't want to go up the hill, whatever. It's all just so easy now. And it's replaced like 90% of my bus trips altogether.
Oh, that's awesome. Yeah, San Francisco, you need the motor. In Amsterdam, everything's flat.
Right.
But,
Who's your? Do you have an early bet on who's going to become the Tesla of electric bikes?
I'm very excited about a local brand called Van Moof, and they recently launched their new electric bike, and it has like a digital theft protection system. So you just lock it by pushing a button, where normally you need these really big chain locks in Amsterdam. And they have a GPS and Bluetooth inside, which you cannot take apart. And so Van Moof guarantees that they will look for the bike if it gets stolen, and if they can't retrieve it, they will give you a new one on their expense. So,
Yeah.
I think that's a whole, like, the bike theft is a really big problem in Amsterdam.
Sure.
And it's such an innovative approach to this problem.
Yeah. So it's like a bike theft replacement as a service.
Yeah, exactly.
Excellent. Bram de Zwart, thank you so much for coming on the program today. It was great speaking with you.
Yeah, likewise.
Bram's co-founder, Brian Garrett, is speaking at the Digital Factory conference. If you want to meet him, as well as the CEOs and CTOs and CIOs who are remaking manufacturing, head to thedigitalfactory.com and sign up using the code PODCAST for a discount. For the Digital Factory podcast, I'm John Brunner.